This episode is brought to you by WeatherGuard Lightning Tech. At WeatherGuard, we make wind turbine lightning protection easy. If you're a wind farm operator, stop settling for damaged turbine blades and constant downtime. Get your uptime back with our Strike Tape lightning protection system. Learn more in today's show notes or visit weatherguardwind.com/striketape.
Welcome back. I'm Alan Hall.
I'm Dan Blewett, and this is the Uptime Podcast, where we talk about wind energy, engineering, lightning protection, and ways to keep your wind turbines running. In today's episode, we're going to talk a bunch about lightning strikes, some articles. Obviously, it's summertime, so there is electrical energy all over our marvelous planet. So we're going to talk a little bit about that. Vestas has been having some lightning warranty issues. Obviously, again, it is the summertime, so that's not surprising, but they've reported a $175 million loss because of additional warranty issues. So we're going to chat through that. And then in our second segment, as we talk about engineering, we're going to talk a little bit more about O&M contracts and the idea that a lot of these wind turbine manufacturers are maybe going to lose service contracts to their own customers who are potentially going to bring operations and maintenance in-house to save money. So Alan Hall is here with us. Alan, how are you doing?
Great, Dan. Boy, this Vestas lightning issue was really surprising when it was announced. I haven't seen any numbers nearly that high in terms of lightning strikes for any particular OEM. Wasn't that, does it just seem like off the charts, a massive amount of money?
That's a lot of dough, 175 million. Yeah.
Yeah. I can't, they didn't, the one thing that was asked, but I don't think answered was, how many blades are we talking about and where? And that didn't get answered. So that will trickle out over time, I think, if somebody's really on it. But in terms of financial numbers, did you watch the Vestas stock after the announcement? It went up.
No, I didn't.
Yeah.
Did it?
Yeah, it did. It went up. And I thought, well, okay, so they had a pretty good, I think if you just discount that one-time $175 million loss, essentially, or fee to fix the blades, the rest of it was very positive. And Vestas is in a really good position right now. I think that they're just financially sound. They have cash flow. They got great products. Positive things are happening there. But boy, talk about, we've never seen anything like that. I haven't ever.
Well, I find the stock market fascinating in its irrationality, which in my limited studies of it, and I should disclose, I own Norwegian Cruise Line stock. I bought it recently at a very, very steep discount, mind you. And I plan to keep it for a while, so I'm not concerned about its fluctuations. But I watch them, which is, again, fascinating. They're a good example. So I bought it around 15 a share and recently went down to 13. I'm like, and then when there was news, I woke up one morning, I look at the stock and it's at 16. I'm like, oh, what happened? There must have been something important. Nope. This little notion of a Russian COVID vaccine coming out was enough to jump the stock from, 25% in one night.
Wow.
No, literally there's no cruise ships moving. Nothing relevant
Nothing has
to the
happened.
business has been reporting, except some speculation that there might be a vaccine, which is, to be honest, precisely the reason I bought it. The company's not going to go under in the next year. They have tons of cash they just raised. So as soon as there's news, that stock might, an actual vaccine, the stock's going to shoot up and I'll probably sell it and whatever. But anyway, my point here is that when you look at these fluctuations in the stock market, they are not rationally tied to the business in many, many cases. A lot of times they are, obviously, but in many others, they're not. So that doesn't surprise me that with bad news of the stock here with Vestas, that is still maybe going the other way.
Right. Well, I think that, there's a lot of money floating around being pumped into economies right now, even though it does seem like a substantial number of smaller businesses are really struggling with all the COVID things. That particularly the power industry is one of those industries that power is always needed. It seems like there's cash inflow into those as investments right now, just because of the stability of the electrical market is not going to go away relative to other kind of marketplaces like cruise lines. So I I think that's part of it. Siemens Gamesa has gone through some reorganizations recently, and they're talking about reorganizing or splitting the wind turbine section off of the larger company. It's probably again another good move because it has value there. But you're right, it doesn't, with all the in theory calamity of the economic conditions and COVID-19 and all the things that are happening in the world. The one thing that's not fluctuating all that much is the overall stock markets in any part of the world. We haven't seen huge collapses, which is either indicative of people taking a long-term view or people just not participating, one or the other. So I'm a little uptight about what's going to happen in the wind market. At some point, is that going to turn around and go negative? I don't think so, but things are just seem like they could go either way right now, which is really hard to swallow.
Yeah. Well, so let's get back to Vestas specifically. So what do you attribute this huge loss in warranty claims? Obviously, they're saying they're having lightning issues. They're not disclosing on what models, on what blades. They said it's specific to some and not others. But what is your speculation here about what this might be?
Well, they describe it it's an interesting description, the way that it was talked about, because it said that the turbine blade issues related to quote unquote high intensity lightning. So high intensity is either high quantity, like frequency, or high amplitude, maybe a combination of both. There's only a couple places in the world where I would think there'd be high intensity lightning, which would be Japan, Italy, in some parts of the United States, Florida, for example, it could be high intensity lightning. But Florida doesn't tend to have a lot of wind turbines, surprisingly.
And what amperages would you qualify, you being a lightning expert, would you say are high intensity? Where's the cutoff
above
point?
100,000 amps, I would say, is getting to be large.
Okay.
And in Japan, that's relatively commonplace, but that tends to happen in the wintertime, not in the summertime. So that also makes me think like something happened over the wintertime in Japan, and now we're trying to correct it in the summertime when the weather's good. It sounds like a northern hemisphere problem. Most likely it is. But they didn't define where in the world it was. They didn't describe what the issue was or what the repair was. For $175 million, you got to wonder if they're replacing whole blades. That's what it screams to me, that we're replacing whole blades, that there's something intrinsically off in the production. I can't imagine it. Well, it could be a design issue, but more likely it's a production issue or a lifetime issue that's popped up, because that's a huge number to swallow.
What's the typical cost to replace a whole blade?
Well, with the crane,
widely,
well, it depends on how you're going to get it down. It's a lot of costs in the crane. You're talking $250,000 plus. Yeah.
And if it's up in the, I love those videos where they're carting a turbine blade up the mountains on the truck with the dolly, and they're weaving it. It's fascinating.
Yeah.
And I'm sure it's terrifying. On one of my other podcasts, I had a former baseball player who drove I can't remember. He said he basically drove like one of the heaviest commercial trucks for a period when he worked in the oil industry. And he after he finished his pro baseball career, he was briefly working on in Texas on he just quickly jumped into the industrial sector and was pretty good at that whole line of work. So anyway, he got his commercial driver's license, and he said he's like, dude, this one day I was just driving this really heavy truck going down a really steep incline, and I was just sure I was just gonna we were just gonna all die. It was just terrifying. Just this huge vehicle with this huge heavy equipment on it, and I know what I'm doing, but it's just so treacherous sometimes. And to have that perspective was interesting, because you think, oh, you're just driving, but I mean, these routes that these blades travel on up through the mountains into the heavens, it's crazy, and it's so precise. And I mean, those guys I'm sure they have to we need Wild Bill to take this blade up here. I'm sure they have their guys, right? In the
special guys
in the aviation. Yeah. Well, in the aviation industry, they have those legendary test pilots, right?
Yeah.
That they're only going to call this guy for this crazy new plane because he's the guy that can wrangle it, kind of thing. I'm sure it's the same way with some of these these shipping jobs that just seem so intricate and difficult.
Oh yeah, if they had to switch a blades, so there's two problems. One, getting the existing blade off and doing something with it, because a lot of times just leave it on site, and then obviously try to get a new blade up there. That's a little more difficult task. Just, the numbers don't make any sense without that happening. If they're going to, I want to call a band-aid, put a bandage on a blade and try to improve the lightning protection, it should be nowhere near $175 million. Like, that's not really possible. So it's something larger. Something larger.
Something's lurking. So let's talk about this other article coming out of, looks like in Spain. So just talking about the frequency of lightning strikes, which you're well familiar with, that every minute on the planet, 2,000 lightning strikes are occurring all over the world. It's the summer, and I know there's a lot of, obviously this is like high season for it, but there's also a push to develop technology to be better at detecting these strikes. But like you said, there's no force that's going to like, oh, we detected a strike, let's just go ahead and push the button and stop it. Like, nothing's happening. Like, it's just like, oh, this is going to happen. So is lightning detection technology useful? Is it useless? Like, what are the pros and cons here?
I think its real function is to help locate where turbines have been struck and to do some inspection on them without trying to look at every possible turbine every time there's a thunderstorm running through. I think that's what has value. It can have value on the insurance side to say that damage to that blade was a lightning event, not a structural issue with the blade or the turbine itself. Those kind of insurance disputes you can provide data on and help settle arguments. But beyond that, there's just not a lot of added value there. Obviously, if you're a technician, I think there's a ton of value, so I don't have to go look at 100 turbines today. That's awesome. I'm going to look at 3. That's a lot better. From a sort of O&M and site manager, I don't know if it makes a huge amount of difference. That's why I don't see it has gained a lot of traction. I think what you're seeing now is more. And we got a couple of phone calls about this recently. People are looking for information about each particular blades, like instrumenting each of the blades in the turbine, so they know exactly if a blade has been struck, and to go look at that particular blade and have information about that strike will tell them a lot more information. And it's the way that the data systems are set up today. They're transmitting all that stuff to your cell phone, so you know immediately where to go. So that's even a better look at it. But if you're in a remote location, you can't afford that kind of thing, or your turbines haven't been instrumented for it, then some of these services can help.
Yeah, and that makes sense, because I mean, this happens in all, especially in like the sports and fitness industry, where data is also, I mean, data is growing in every industry, right? Like,
oh yeah,
I'm sure the wind turbine industry is overrun with the amount of data, and this is happening even in like sports. I mean, baseball is a great example to bring it back up, and you have to start to draw the line when it's like, okay, we could track this, but then what are we going to do with this data? Do we fix something with it? If we don't make something better and solve a problem, we don't need the data. Like, let's not track it if we can't do something useful with it. And I'm sure there's carryover here where, like you said, it does make sense to say, hey, this blade got struck, we need to send someone out. But if you don't have the capability to do that, like, we don't need to track it. Like, we don't want to track everything that's not actionable. And if it's not actionable, let's just let it be. We don't need to overload, because then, I mean, you have people who are I'm sure overrun and overwhelmed by all this data. It's like, what do we do with it all? We have a million technicians, but they're all doing real things,
right?
And you just have a pile of data that isn't useful.
It isn't useful. So, no one looks at it. No one analyzes it. No one puts it into productive things. Yeah.
All right. In our engineering segment here, let's talk about a interesting new trend that's probably going to shape the industry for years to come. So this is out of Green Tech Media, reporting by Jason Dane. So wind turbine makers, and this is an interesting headline, they're facing a growing threat to lucrative service deals, their own customers. So service deals have been, they've been making a lot of money for these companies, for the turbine manufacturers themselves for a long time. Doing the service deal continues to, just like anything else, like your car manufacturer, you sell a warranty, you want people coming back in to sell parts. But Now it seems like people who are buying these, the wind farm operators, are saying, nah, we can do that in-house. We want to do that ourselves and save money and try to get parts themselves. So what's your take on this, Alan?
I think the industry has a long way to go to figure this out. And the wind turbines are getting to be a size where we can't play anymore. As we cross the 2 megawatt threshold, and now we're talking about 12 plus megawatt systems. I understand the need to bring those service jobs back in house, because you can manage the inventory, you can manage the cost of particular components better, you can manage the labor a little bit better. You're not paying a quote unquote middleman, you're not paying the part markup fees, but there's a consequence to that, and the consequence is that as a operator, do I know all the design details? And let's just talk about the blades for a minute. Do I know the design details on the structure of that blade? Like, do I know how many plies of fiberglass are in it, or how many carbon plies are in it, and why they're there, and what happens if, and how to repair that properly? I don't know. When you start talking about complex carbon fiber, fiberglass structures as big and massive as these are, they're not simple objects. So you either have to have a really good fundamental understanding of how those things work and have somebody who's knowledgeable how to fix them, or you need to rely upon the OEMs. Now, there's always I think there should be a compromise here, which has sort of been developed in the aircraft world for a long time, which is you can't just willy-nilly put a car part on an airplane, even though they may be made by the same company. You can't just willy-nilly throw parts on an airplane. And the reason for that is safety related, because they found that substitute parts didn't work as well, or weren't designed, or the person who installed the part didn't realize that the part wasn't designed to the same level of rigor or same material strengths or performance as the aircraft part was.
Yeah.
And
a bolt could look like a bolt.
Yeah,
a nut could look like a nut.
It does,
but it's not.
It's not. And helicopters, it's been a problem for a long time, because bolts are expensive because they're high strength, and people would substitute or fake it. There's a fake market for a long time. There still is. You get bolts in about once a month about fake parts or unauthorized parts being used. I think on the wind turbine market, we're kind of getting to that point of there should be a listing of all the stuff that's there and its appropriateness. And if someone wants to build a replacement part for that, they got to be able to show that it meets the OEM standards. Now, that gets hard because the OEMs don't want to give that away. So if I'm wind turbine company A, why would I want to tell this small mom and pop operation how to make my part, because they're going to compete with me? But yeah, they're going to compete with you anyway. The question is whether the part they're going to use, that the operator is going to use, is appropriate for the wind turbine, so that you don't have a safety risk. Those need to be balanced, I think. And in the aircraft world, the FAA and same thing in EASA. EASA is even tighter restrictions, and the Europeans are much tighter restrictions than the Americans are. But you got to have a sort of some fundamental approval process. It just can't be all cost driven. And we see that with our strike tape product all the time, that our strike tape product just delivers years and years and years of life. And there's some knockoffs out there that do not, and they last for a couple of weeks. So, wind turbine operators don't really know the difference, and there's no verification validation program, so they'll just pick whatever's cheaper today and not realize that they're putting the wind turbines, a very expensive thing, at risk. Because there's no process. There's just no process. There's no regulatory. And I'm not a big pusher for government regulation here. I don't think it needs it, but there has to be some sort of industry regulation on what the heck's going on, and we just haven't reached it yet. So the pendulum is swinging, right? The pendulum was all in the OEM court, and now it's kind of swinging the other way, where it's going to be in all the independents and the operators court, and then it's going to come back because it's going to go too far, and we're going to find that happy medium, but it's going to take a while.
Yeah, and you just hope that something catastrophic doesn't happen to where, like you said, like someone's using cheap bolts from China or wherever.
Right.
And something really disastrous happens. And then everyone's like, okay, now we need regulations. Like, you hope it just like happens before that point. But A lot of times that's what it takes, right? I mean, that's been the state of the aircraft industry, right? I mean, aviation, they have had crashes throughout the years, and after every crash, they get better.
Yeah.
So maybe it takes that kind of stuff to open eyes. A lot of times, as unfortunate as it is.
Right. And if you're the upper level management of a wind turbine OEM, you don't want to be drug in front of your national government to explain yourself, because that's what happens in most cases on the aircraft side, is that they'll drag the head of Boeing out in front of a congressional inquiry and give them the third degree, and it's just bad PR all the way around, right? So it forces companies like Boeing and Lockheed, and you pick any of the aircraft companies around the world, have realized, like, hey, there is a secondary market for parts. We don't have to promote it. We don't have to discourage it. We just want it to be safe and let it go at that.
Well, and does the same thing need to happen for providers? I mean, a good example I think of is here in the U.S. If you start talking about like German automobiles, like, my family, we had a Volkswagen when I was growing up. You couldn't take a Volkswagen with like a turbo to just any auto mechanic,
right?
Because they just didn't they're very technical, and so you want to either take it to the Volkswagen dealership or to someone who specializes in like Volvos, Volkswagens, Mercedes-Benz, whatever, who are like, we're really top notch at servicing these,
that's right,
German-made cars. Yeah. So is there something like that probably needs to happen as well, where people have like, all right, I'm a certified provider, or is that already there?
It is and it isn't, in a sense. It's kind of halfway there. Just because the industry is still relatively young, I think that's the issue. As it grows up and the financial risks get higher, it starts to get smarter as it tries to minimize downside risk, and that's one thing that'll happen. It'll start to provide standards and start to force itself to be better. There's a sort of an equivalent in the aviation world, which is the airlines tend to have their own ability to repair their own aircraft or to make modifications to them and record them, justify those decisions. But they have an engineering staff there that does that. Now, you got to be able to afford that. If I'm a wind turbine operator, if I'm an Iberdrola, I probably have enough engineers to do that, just because I'm a large corporation and I have resources to do that. If I'm operating 100 wind turbines in the middle of South Dakota, I probably don't have the ability to have 5 engineers on staff all the time to take care of that stuff. Right. So in the United States, on the aviation market, the small airlines have had trouble. Same reason. That same sort of reason, you just don't have the resources. So there is parts of scale here that matter, where you have to have enough money to support the engineering.
All right, well, we're going to wrap up today's episode of Uptime. If you're new to the show, welcome. If you're a regular here, thank you for your continued support. Please subscribe to the show and leave a review on iTunes, Spotify, or wherever you listen to podcasts. Don't forget to check out the WeatherGuard Lightning Tech YouTube channel for video episodes, full interviews, and short clips from each show. For Alan and all of us at WeatherGuard, stay safe, and we'll see you next week. Is downtime causing you financial pain and putting a stop to your power production for months on end? It's no secret, lightning strike damage is a major cause of wind turbine downtime. This damage is preventable with our easy-to-install strike tape lightning protection system for wind turbine blades. Our incredible engineering, build quality, materials, and edge sealants withstand up to 5 times more abuse in the toughest weather and lightning conditions. And we've got the research to prove it. If you're tired of constant downtime, we can help. Reach out to us at weatherguardwind.com and schedule a free call. We'll get your uptime back in no time.